Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. Now we're focusing on ellipses, okay? And we're going to talk about what that shape is and what the parts are. And eventually we're going to work on how you take a look at an equation of an ellipse and be able to graph it. Now an ellipse is part of what we call conic sections. And that means we're going to slice through this cone. It could be the bottom one or the top one. And you're going to get a curve here, which is kind of a flattened circle. And of course, its name is called an ellipse. An ellipse shape is a circle that's been flattened in one direction or another, or even stretched, if you want to think of it that way. And just like a circle, it has a center right there. And I want you to think of it as almost as if you start with a circle and you stretch it side to side, so you kind of end up having a couple of radii there, a radius that kind of moves out over here and a radius that moves out over here. Now mathematically, those new radii are called focuses or foci. All right, foci. And that's actually another video. It's a little more complex, and we're not going to get into that. What we're going to focus on is the actual formula, which looks somewhat like this. We have x squared over a squared plus y squared over b squared, and it has to equal 1 in order for this thing to work. All right? Now let's go ahead and focus on a squared. What is the a? Notice it's an a squared value underneath the x squared. Okay? Now a itself represents half of the major axis. All right? In other words, from the center, we're going to go out a distance of a to the left and a to the right. So the entire major axis, the longest part of the ellipse, is the distance of two a values. All right? So in the formula, you would look at what a squared is, take the square root of that amount to find a, and you'd go in that direction to the left and to the right. Okay? So along the x-axis. Likewise, the b squared underneath the y squared over here, well, the square root of that amount then would be b, and b actually represents the length of the minor axis. So from the center, you're going to go up a distance of b and down a distance of b. And the entire minor axis, how thick the ellipse is, at the narrowest point, is 2b lengths. So b is 1/2 the minor axis. A is half of the major axis, B is half of the minor axis. So if you have an equation in this form, you can immediately find how wide, left to right, the ellipse is and how tall it is up and down. Now let's add one more complication to this, and the typical version of the ellipse formula is this. Instead of x squared, we have x minus h squared. There's an h value that gets put in there. Also, instead of y squared, it becomes y minus k squared. So what does the h and the k represent? Well, the center of this ellipse is h comma k. So the ordered pair of where the center of this ellipse is the h value and the k value. All right, and that'll be, of course, this point right here. So it's important to note that if the equation is in this form, you want to pick out the h and the k value if it's shown for you, and that's where you locate the center of this ellipse. And then you can look at the a and the b values and stretch it out from there. So when you locate those 4 points, those are called the vertexes or the vertices. All right? In order to graph an ellipse, that's what you need to know. So you locate the center, you find the minor axis and the major axis, and then you go out from there. So you have a vertex on the right, a vertex on top, a vertex on the left, and a vertex on the bottom. And once you locate those, you could kind of substitute in a few points and find a few ordered pairs to develop your curve. But basically, if you're talking about a sketch of an ellipse, it would look like that, a flattened circle. All right, let's try a few examples. All right, let's look at x squared over 16 plus y squared over 49 equals 1. All right, now on purpose I've started with a kind of a simple one, but notice how we do not have an x minus anything up here, so the h value there must be 0. And same with the y, it's y squared, not y minus k of some kind. So the center of this ellipse must be 0, 0. So let's just kind of put a little mark right there, and that's our starting point. Now the 16, of course, is actually 4 squared, and the 49 is 7 squared. So the a value must be 4, and the b value must be 7. All right. Now in this case, a is 4, and that means on the x-axis we're going to go out 4, and put a little mark right there, and same direction in the opposite way. And because 7 going up is taller, then it actually becomes, this a here is going to be your minor axis, and the major axis is going to go up and down 7. So right there and right there. All right, let's draw an ellipse and get that all figured out. All right, I've drawn the ellipse, and now let's place it in its proper spot, and let's see if we can get it to work here. All right, there it is. So we have a major axis here of actually 8, because it's 4 going in both directions, and the minor axis is 8, and the major axis is 14. There you go. All right, pretty easy. Let's try another one. Here it is, x minus 4 quantity squared over 64 plus y minus 2 quantity squared over 9 equals 1. All right, let's locate the center, which would be at 4, 2. So positive 4, positive 2 over 4 and up 2. So we're going to locate the center right there. All right, hopefully you can see that. Since 64 is really 8 squared, then the a distance must be 8. And 9 is 3 squared, so b must be 3. All right, so from the center, not from the origin now, because we did a little translation, a is 8, so we're going to go out 8, put a little mark right there, and then to the left, 8. And your major axis there is a total of 16, 8 in both directions. Now if b is 3, we're going to go up from the center 3, put a mark right there, go down 3, put a mark right there, and that is your minor axis, which is 3 on both sides, so that would be a total of 6. All right, now let's draw the ellipse. And that's what that ellipse looks like right there. All right, one last example. Take a look, and we have x plus 5 here in this equation, quantity squared. Remember that the formula is a minus there. We have to have a subtraction value. So we need to think of it, or rewrite it at least, as x take away negative 5. All right, so now our h value is a negative 5. So the center is going to be back 5 from the x-axis, and actually up 4, because now our k value is a positive 4. So the center is negative 5, positive 4. All right, let's go ahead and locate it right there. All right, and now remember that 16 is really 4 squared, so a must be 4. Okay, and that's our one of our axis distances from the center. Now 10 means that b is going to actually be the square root of 10. Okay, we don't always have perfect square numbers here. Now think about the square root of 10. Well, square root of 9 is 3, so square root of 10 will be a little bit more. Let's call it about 3.1, 3.2. We'll say 3.2 approximately. All right, that'll get us at least close to being able to draw this ellipse. All right, so we have the center located, and now we're going to go out in right and left a distance of 4. So put a little mark right there, and put a little mark right there, and that's our axis there. Okay, our major axis actually, because it's longer. Now up from there, up from the center, we're going to go up 3 plus a little bit more, so maybe guess about there, and down 3 and a little bit more, so right about there. All right, let's draw the ellipse. All right, that's what that ellipse looks like. Again, watch the signs there. If you see a plus, you have to rewrite it as a subtracting a negative there. So you locate the center, and then you figure out how wide and how tall the ellipse is with the A and the B values. All right, next video is a problem set. I'm going to show you some equations like I have here, and you're going to graph the ellipse. So give that a try. Thanks for watching. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard and take care.